Hello people, welcome to It Learns. Today we are going to discuss a very basic and widely used concept, that is logic gates. First of all, what is a logic gate and why and where do we use it? Logic gate. A logic gate is basically an electronic circuit. It's an electronic circuit that is used to perform logical operations. Alright, so now we know what is a logic gate. It's an electronic circuit that is used to perform logic operations. Now, what is a logical operation? A logical operation is AND operation or operation, or you can say a NOT operation. These are three basic logical operations. So any circuit that performs an AND operation is an AND gate. Circuit performing a OR operation is an OR gate, and a circuit that performs a NOT operation is a NOT gate. So now we have here that what is a logic gate and where do we use it and what we can do with them. Now let's get this explained in brief. So types of logic gates. There are three basic gates and four derived gates. What are the three basic gates? Basic gates are three we have already discussed above, that is AND gate, OR gate, and NOT gate. Now the four derived gates: NAND gate, NOR gate, XOR gate, and the last one is XNOR gate. So let's move on to discuss these basic gates. The first one we have is an AND gate.
Not to re-sign with Kookaburra and juggle their.
So any circuit, electronic circuit of course, that performs an AND operation is known as an AND gate. So now what is an AND operation? Dot product of two inputs is an AND operation. How do we represent this? And how do we represent the AND gate? In fact, an AND gate is represented like this. We take two inputs, get the dot product of both, and we get the input in form of Y. So we have two things here: algebraic expression for AND gate, representation. Now let's move to the truth table. Now what happens if the current is flowing through P. Of course, we are talking about electronic circuit, so we are talking about currents and voltages. Now, if the current is flowing through B, it has a value 1. If the current is not flowing, it has a value 0. So the value for representation sake, an closed circuit or when current is flowing through the nodes, it's represented by 1, and if not, it's represented by 0, and rightly so. So here can be a combination that the current might be flowing from in A, that is the value is 1, and the current might not be flowing through B. So this can be the combination, or vice versa. So what are the possible number of outcome combinations that can be there? So to determine them, we have a formula that is 2 raised to the power n, where n equals to number of inputs available. Okay, so here we have the number of inputs are 2, so the possible combinations are 4. 0 0 0 1 1 0 and 1 1. So by using dot product formula, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is also 0, 1 into 1 is 1. So we will be getting an output in case of an AND gate only if the current is flowing or the value of both the inputs are 1, except that if there is current flowing in only one of the inputs, will not be getting any output. Alright, so now let's move on to OR gate. Okay, in an OR gate, any circuit or electronic circuit that can perform an OR operation is an OR gate. What is the OR operation? Addition, of course, that can be represented as x plus y, p plus q. And how is the OR gate represented? We can have 2 or more inputs. Alright, so here number of possible combinations as same as the AND gate. Now let's move on to the truth table. We have the representation and the algebraic expression, that is alright. So let's move on to the truth table. Possible combinations. Addition, binary addition, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Now you see the difference between OR gate and the AND gate. In an OR gate, AND gate, let's have the AND gate outputs as well. See the difference. In an OR gate, we'll be getting an output if either of the outputs are 1. That means either of the inputs are 1. If either of if in an OR gate you will be getting an output if either of the inputs have a value 1, whereas in an AND gate you will be getting an output if both the inputs have a value 1. Alright, and now let's move on to NOT gate. Now we move on to NOT gate. NOT gate is basically the simplest gate, also known as inverter. You will see in a short time why I'm saying so. A NOT gate is represented as this. It can have one or more inputs, and when I say this, in an OR and AND gate you can have 2 or more inputs. So when you see the difference, the minimum inputs in case of OR and AND gate are 2, whereas it's 1 in case of NOT gate. Now the algebraic expression for NOT gate is the output Y is the complement of input A. So whatever goes in, the complement of that or the negation of that comes as an output, and this bubble here represents the negation of the input. And when we come to the truth table of NOT gate, number of possible combinations is 2 raised to the power n, whereas n equals to 1, that is 1 input. So we have 2 raised to the power 1, that is 2 possible combinations. A and Y we have 0 or 1, so the output is going to be negation of 0 is 1, negation of 1 is 0. So 0 comes in, 1 goes out, 1 comes in, 0 goes out. This is the truth table for NOT gate. Now these are the 3 basic gates that we have discussed. Now we are left with the derived ones, and we'll discuss that in the next video. Till then, keep learning, and please do not forget to like, share and comment, and please subscribe to the channel if you like this video. Have a nice day.